So this is a continuation of our Atic Atac videos. In this one we look at the data format from the original game and we convert it into our native format. So we have to write a tool for that. So yeah, let's get cracking after the fade. So we have a room. So our room is, well, it can actually, for now it can contain 4 exits. So each room has 4 exits, or at least the possibility of 4 exits. In the game, that's not strictly true because some rooms actually have just 2 exits. So they might have like a, we'll call this a sort of north, east, west, south. So they might have a west and east exit or a north and south exit, but you know, it doesn't really matter what rooms there are. I mean, there are rooms as well that have got this kind of setup as well, where there are 2 north doors. So we're going to have to figure that sort of special case out there, because in theory then that means that we could actually have doors in sort of these positions inside the room. Now, some of the rooms are square shaped and some of the rooms are rectangular shaped. So some kind of have this kind of look and some have this kind of look, and the other ones are the square ones that I've drawn there. And each one of these represent doors, by the way, in case it's not obvious. And each one of these have doors in different places. So that's kind of where we are just now, is that we have to figure out a sort of algorithm type setup thing that we can have all these doors in different places, turn them on and off, and basically describe the room. Now the room also has other attributes to it as well. So there's the wall color, that's wall color, number of doors, and that includes placement, placement of doors. It's also got special things as well. So I mean, that was my machine going boom. It could also have special objects as well. And it could also have monsters. Now, monsters aren't the things that spawn, those are the things that are in the room already. So there's a mummy, there's a vampire, I think there's a Frankenstein as well. And those are permanently in those rooms. So each room inside the haunted house has certain attributes associated with it, and we're going to have to code that into our room as well. So we're going to have a data type for our room as well. And we're going to use I'm going to have a look at the source code for Atic Atac, and we're going to see what we can get from there. I do have the source code downloaded also from the iSmart website. So what we might do is we might write a little tool that gets that information, extracts it, and then we have all that data in like a decent enough format that we can use. It'll probably be a binary file, maybe a JSON file. I haven't decided yet what we're going to do for that, but that's the kind of things that we need to sort of think about. So we have our rooms, so we need to find a way to describe the rooms. So we need to have the ability to have these objects here. Now each door placement is going to be north, south, east, and west. So we're going to have to look at the excuse me, have a look at the source code to find out where these things go, because we want to keep this as close to the original game as possible. We don't want to sort of deviate from it. So yeah, I mean, I guess this is the kind of meetings that they would have back in the 80s when they would be deciding, you know, in an arcade conversion, what can we keep, what can't we keep, that kind of thing. So okay, so that's what we're going to do just now, is we're going to find a way to describe this room here based on the source code. So let's go and take a look at the source code then. Here's the format of the screens. Well, here's the data for the screens, and you see that it's in text because this is the source for it. So what I want to do is I want to, where are we? I want to write this out. So it says the screen table has an entry for each screen. The attribute is the color for the screen, and then the type is the type from the following list. So offset is 0, byte is 1. Now let's just count how many lines there are here. So that's Are there 151 rooms in Atic Atac? Well, let's go and find out. Atic Atac map. So I make that 140 rooms. So why the discrepancy? Are there other rooms that don't exist? I worked out we have 151 rooms. The last ones of these, 1, 2, 3, 4, these are all, well, sorry, they're black, so that would describe it as a black room. So 0 multiplied by any color is, of course, black. So, yeah, and then this room is also black, but it is room 12. So I think that's the final room. I guess that makes sense, because that's the room that's hidden. So they have other rooms, I guess, that are also hidden. I mean, any room that's in this column that's got zeros against it is hidden, technically, as well. So, okay, well, we'll see what we've got. Alright, so what we want to do is we want to get the attributes for this screen and then the room type for this particular screen. So we're going to have a certain number of room types, and then that's going to get us to there. So this one is these objects here, though it says background items, table of all background items for the screen. If an item is connected to another item on another screen, then the item it is connected to is either before or after the entry, depending on if it is an odd or even entry. Whew. Okay, so these are how the screens are connected. This is the most backwards format I've ever seen. So the items determine what screens you go to. I guess that makes kind of sense because, as we said, and I'm not going to go through it again, but we can have 3 doors. So technically they could have any number of doors, and those doors then lead on to the graphics before that. So I guess it kind of does make sense to have it that way, but we're going to have to get the rooms and describe those rooms anyway. So so I mean, really, we probably want to get these items as well. Used if table tile, used if trapdoor, used by rug, flags. I guess the rug, so the rug you can walk over. So that's why it needs to be used as a flag there. We can figure that out later on. Okay, so do we have 6-4-D5, 6-4-D5? What is in here? Are these the objects? 6-3 background tables. 6-4-5D background items. Okay, I guess really we want to start looking at these ones rather than the ones I thought we were going to have to look at. Okay, so this is a lot of text. So what I'm going to do is I am going to go and create a new project that is going to read in these lines and then create a structure from that. And then from that structure, we're going to save that out as a JSON file. Because why not? And so for that, okay, well, let's get this into the right format first of all. So I am going to create a new project. And I'm just going to make this a console application. And I want to store it in here. And I want to call it tools. Let me just create a folder here called tools. And I'll put all this, so I've created a GitHub repository. I'll put the link in the description below. But basically everything I do here on the screen is going to be in the GitHub repository. So you can take a look at my wonderful tools in here. So this one is going to be, what are we going to call this one? I guess object data creator. I don't know, for lack of a better word. And we just want, I did a video, if you haven't checked it out, I'll put a link up there. I'm trying to look at the monitor there. I'll put a link up there. Basically, it's showing you how to do command line tools. A lot of game development is command line tools or writing tools for game development. So you might as well get used to it. Okay, so I'm going to create, this is the background table here, and I'm going to cheat, and I'm going to use, and again, I'm going to use a tool. I'm going to use Sublime Text Edit, which if you don't have as well, I think it's $80. It's a great text editor, and I highly recommend it. It's saved my skin a few times for doing development work. So I want to take this here, I want to create a new file, and then that new file is I'm just gonna rearrange some of the things in here. So things that we don't need, like for example, we don't need all the H's in here, and we don't need all the DBs either. So I am going to do a search for all of them, which is a lot. Actually, I could probably do find all. And then I can go whoop and delete all of them. And then I can do the same thing with all the H's, because I don't need them either. So I can find all of those. Find all of those. Why is it not finding all of those? Okay, that's kind of weird. Why is it not finding all those? Well, it doesn't matter. We can work it out in post. Okay, and I want to save this in. I'm going to save that to Object Data Creator, and I'm going to call this our object source.txt. So that's our object source.txt. We're going to copy it anyway, but at least we'll have a copy over there. So there's our object source.txt. Okay, now what I want to do is, I know that the format is this, so I am going to say fr0. So I want to check to see if the user has typed in a valid number, if the user has typed in a valid file name, and if not, then I'm going to display an error message and then say the usage is this. Otherwise, I'm going to process the file. So I want to do if string.isNull or empty. What's this called? Object data creator object file.txt. Else. What do we call this? Background items. Okay, so this is going to be creator. And again, I haven't created this class. This is a class that we're going to create, and I made a mistake there. So I wanted a new line here, so I did /r /n. Those are escape characters. They're just used inside strings to make it a little bit condensed as to what you're meaning. So I wanted to create a new line between usage and object creator in that next line, so that's what that is. And you need to do /r /n because we're on a PC. So meter equals new create background items creator, and then we're going to put in args0 as the file name, and then creator.run. So this is just going to generate a JSON file, which is going to be called background items.json. So I know this doesn't exist, so I'm going to create it by, it says generate class background items creator. I didn't want that. I want to create it in a new file. And this does not have a constructor here, so I'm going to create that constructor. And this does not have a run method, and I'm going to create that run method. And now my basic class is done. All the hard work is now inside my other file, which is background items creator. And all of this, see all this helpy thing? A lot of people think, oh, well, you know, you're not going to learn the language, blah, 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 all that kind of stuff. It helps you, all this helpy stuff helps you get to fix the problem. That's, as a programmer, and we're both programmers, that's really what your job is to solve the problem. So the problem at hand is, I need to get this from one data type into another data type. And there's only one way I can do that, and that way is to extract the information as from this particular file, and then get it into another particular format. And that's what I'm wanting to do just now. So path, and then I don't want this here. Actually, I did want that. String path. Okay, right. And I want to read in this file here, and then from this file here, I then want to pass in, because this is a binary format, and it's actually in this format here. So I want to create a structure that's got this, but what I want to do, I want to be able to read that in, I mean, I could do it in, oh, let's just do it in a one-off. That's fine. Okay, let's put that there. So, where are we? Okay, so I want to have add, I want to create another class, and I want to call this background item, and this class is going to have these ones here. So this is going to be public. Okay, that's fine. Public byte graphic. Let's make them get and settle just now. So public byte graphic. The screen this belongs to public. So we probably won't serialize out unknown, because if we don't know what it is, then we don't know what it is. Public byte X, public byte Y, flags, and this is door timing. Byte door flags. Okay, so these are the objects inside here. So this is our screen and our objects. Alrighty. So with the current screen, I then, do they do a linear search then? So thinking back, when you play Atic Atac, every time you go into a screen, it describes the screen, it draws it and everything like that. And I'm wondering if they did a linear search to find all, I don't know if I would have done it this way back in the Spectrum, because when you think about it, the Spectrum was running at like 4 megahertz or something, which is like 4,000 times a second, which is not 4 billion or whatever it is that we've got just now. So that's really slow. So if you're going to have to linearly search this background items list to find each screen, oh sorry, I was a bit missing off there. To find each screen to match it, that's going to take an awful lot of time. So maybe what we want to do is we want to create our data format so that we can merge it with our screen format, so that we have our screen and then we have all the items that describe it with there. And then that's done offline, so that we don't need to do any processing inside the game. Maybe that's a better way to go. Just a thought. Anyway, so let's get cracking anyway. So I don't need properties there. Okay, so I want to run through this. So I'm going to do using stream s equals new file dot open for read path using text reader equals new stream reader s, and I have string line equals, you can tell I've done something like this before, while line equals r dot read line, not equals to null. In other words, while we still have something, process each line. So what does all this do? So the usings are great because stream reader and text reader are both disposable objects. So what that means is when you've used them, then you need to call dispose and then finish and close them and dispose them. Wrapping them inside a using does all that for you, so we don't need to do anything else in there. So we just have our processing part of it down here. So we use the system calls to read in the contents of the file, and then we use these objects to then read each entry in the file line by line. And you see that each entry in the line in the file is going to be that, followed by that, followed by that, followed by that, and so on. And what we're going to do is we're going to take all of these entries, split them up, convert them into binary digits, and then we are going to store them. I guess we're going to have to store them in a memory stream. I guess we are going to have to store them in a memory stream. Yeah, you have to store them in a memory stream, reset the memory stream, and then go back through the memory stream, grabbing these objects here, these offsets here. Okay, so let's fix this up here. So we'll use system.io, and I guess open read. I was so close. I nearly memorized the API calls. Okay, so what are we doing? So we want to process each line. So each line, well, actually what we want to have is we want to have using memory stream ms equals new memory stream. And each line, good, okay. So each line has a set number of bytes. There are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 bytes on each line. And there are 548 lines. So 548 times 8 is 4,384 bytes of data. Let's see if that divides equally into here. So luckily that's right, because we have 8 here. So if I do divided by 8, that means we have 548 objects. So each one of these lines, oh, that's handy actually. Well, maybe we don't need to do that then. Okay, well, we don't need a memory stream then, because we can just do this in one fell swoop. Okay. So, we're going to have byte, what are we going to call this? Item equals new byte. And there's going to be 8 items in that array, because we're going to have 8 bytes. And then we're going to say string raw bytes equals line.split. And then we're going to split it by commas. And we also want to string split options dot remove empty entries. We want to remove the empty entries. So I'm thinking about this as we go along here. We want to remove empty entries just in case we get any blank things for whatever reason. I mean, we're probably not going to get blank lines here, but for whatever reason we might get blank entries here. Because I don't want to get into the situation where it's something like that, and then we end up with blank lines and things, because it just causes problems. So now that split is going to then take each one of these and split them off. Now we only want the first 3 characters. I think all of these are 3 byte aligned. They all look 3 character aligned anyway. So we just want the first 3 characters of that. So we can do for int I equals 0, I less than 8, I plus plus. Do we even need that? Well, No, I don't even know if we need that. Well, okay, let's do it this way, and then we'll create the most convoluted way of doing it. Alrighty. So we want to do for each one of these, we want to say I want to create a temporary string which is going to be raw bytes I dot substring, and then it's going to be the start index of their length of 3, because we only want the first 3 characters. We then want to convert that byte. Well, let's do int first of all. Byte b equals byte int dot. Actually, you can do convert to. We do 2 bytes straight away. Maybe we can. Can we do it? From base. There we go. So we have a from base. So I want to convert that 2 byte from base. So I want to convert temp 16. So we don't actually need this byte. We don't need this conversion here. But of course we don't need byte either, because we can just do item I equals convert to type. So now we have our items in there. Okay. So now we can have list, and this is background items equals new list background item. Of course we need to add our generic. So now we have a list of background items, and we can say items dot add new background item item. So our item is our array of bytes, but of course we don't have a constructor for that, so we're going to go and create a constructor for that. So that's our background item there, and then our background item is going to have a constructor. And so what we're going to do is we're going to say graphic equals item 0. Let's see where this is going. 1, 2, 3, 4, 5, 6, 7. So we have graphic, we have screen, we have unknown. So this is what I kind of mean about your command line tools. They perform a function. They might not be the most efficient. I mean, they should be. But I mean, this is such a small, such a small data set. It's just going to be over like that, so it doesn't really matter. But yeah, you need to. They don't have to be pretty in the inside. They just have to work. They have to do what they're supposed to do. Especially if you're doing something that's a throwaway thing. We're never going to be using this on, like, this isn't going to be part of a big engine. It's just part of what we're doing for this particular game, so it doesn't really matter that much. So I'm going to put a breakpoint there, and then I'm going to go into debug mode, because I'm going to say the command line arguments for that is going to be this file here, which is called object source.txt. Object source.txt. And then I'm going to run it, and then hopefully at the end of this run we should have, well, actually, yeah, the end of this run we should have items in items. So we have 4,384. Isn't that not what we said? 4,384 items. That seems a bit much. That does seem a bit excessive. Because should we not have 548 items? Oh, that's why. That's why, because we are adding them inside the for loop. So the for loop goes and gets all those values, and then at the very end of that, we then add that item to it. So now our item should be 548 items, and now we have our graphic there. So this is for screen 7, this is for screen 0, this is for screen 2, any more, screen 2, screen 5, let's see if we can get something later on. Okay, so this is for screen 34. Okay, cool. And so these are the X and Y coordinates for the actual position on the screen. We're going to multiply these values though by 4 because we want to put them in our space. So this is for a ZX Spectrum, which is, like I said, 256 by 192. We want it to be 1024 by 768. So we're going to have to multiply these values by 4. Yeah, so we get graphic 2 in there. We're going to graphic 2. They're different. These are all graphic 2s. Okay, that's graphic 1, graphic 1, graphic 1. Okay, so the graphics were graphic 1, graphic 2. Okay. I guess the graphic is going to be, what if it's 0? Well, that's a good question. So it can't be 0. All right. Thank you very much for watching. If you liked the video, give a thumbs up. If you didn't like the video, then thumbs down. Please leave a comment below if you didn't like the video, or if you liked the video, then leave a comment as well. So yeah, next time we'll take another look at the tool, or at least we'll continue on looking at the tool. So yeah, thank you very much.